Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient, it'll just be the one I come up with first as I am working through the problem. So today I'm doing another database problem, and this one I'm able to do with MS SQL Server. So this one is listed as hard on the website. This is trips and users number 262. So let's see here. First we have this table called trips. It has an ID, client ID, driver ID, city ID. I'm assuming these are all foreign keys, status, and request at. So ID is primary key. Table holds all taxi trips. Each trip has a unique ID, while client ID and driver ID are foreign keys to the user ID table. Okay. So the user table has both drivers and clients. Okay. Status is an enum, which is either completed, canceled by driver, or canceled by clients. Okay. Then you have the users table, which has users ID, band, which is an enum, and role, which also is an enum. Users ID is the primary key. This table holds all users. Each user has a unique user's ID, and role is an enum type of client, driver, or partner. Band is an enum type of yes or no. To be honest, that's kind of weird that they wouldn't just, why wouldn't you just use a bit field? Oh, I guess bit field's probably maybe specific to MS SQL, and they could just like use a Boolean, whatever. Anyways, cancellation rate is computed by dividing the number of canceled by client or driver requests with unbanned users by the total number of requests with unbanned users on that day. So write a SQL query to find the cancellation rate of requests with unbanned users. Both client and driver must not be banned. Each day between those two dates, round it to the nearest 2 decimal points. Return the result table in any order. The query result format is in the following example. All right, so you have this strips table here, you have this users table, and then you have the output, which is with the cancellation rate for each day. Okay, so we're going to end up wanting the day. We'll figure out what the alias are going to be for these tables in a minute here. Well, this is going to be the request at, actually. That's where we're going to get that from. So, and that's going to be T. I'm going to name that, have T as the alias. At, put it as day. And so once again, it's canceled requests divided by total number of requests. All right, so really quickly, I'm going to make a separate, there's going to be a subquery that finds the amount of canceled orders, which is going to be select count. Let's put this on the same line from trips T2, because this is going to be an inner query. Inner join users U2 on T2 dot. Well, actually, we don't need to join any of the tables because it shows right on here whether or not it was canceled. So we don't need to do the inner join where status in, just do T2. It's either going to be canceled by driver or canceled by client, and T2 dot ID is equal to T dot ID. This is going to be the inner query. So this is going to be this. Let's just see here. This divided by count. Although we do actually need to make sure to exclude. Okay, so we are going to need to do joins because we need to exclude the unbanned users. So inner join users u2. I'm going to put ud2 because this is going to be the driver on t2 dot driver ID is equal to ud2 dot users ID. Inner join users uc2 on t2 dot driver, or not driver, it's the client ID is equal to ud uc2 dot users ID, where that and ud2 dot band is equal to no, and uc2 dot band is equal to no. Divided by the count, and this is going to be the count as, we're going to need to cast that actually, but as cancellation rate. And we're going to need to take this whole thing and cast it as round, as numeric. We'll do 36 and 2. And this is going to be from trips t inner join. So we're honestly going to need to do pretty much the same thing as this. Of course, we'll leave these as regular. Where ud dot band is equal to no, and uc dot band is equal to no. And then actually both of these, since they're aggregate queries, I think we, yeah, that we can just, that one's fine. We can just do a count. This one group by t dot request at. So I just want to test this real quick, because I don't know if this is the way they want us to refer to enum values. So the round function requires 2 to 3 arguments. I apparently didn't. Oh, because this needs to be 2. I believe that's where I need to put that. Okay, trips.id is invalid in the select list because it's not contained. I think for this I want to just have it be t2.id, and, well, wait a minute. If I just run that. It says that I'm trying to select trips.id somewhere. Really quickly, I'm just gonna copy this because I just want to see if this query is able to work. I just want to see what it displays as the result. Yeah, this one's saying t.id could not be bound. Oh, well, obviously, because this is linking to the outside. All right, well, don't link to the outside one. I just want to see if this can run. That can run, okay. So is it because of this row? It is. It's because this row has t.id. Oh, yeah, we just want to make, actually we're using the wrong column, that's why. The t.request at needs to be equal to id.request at. Okay, let's see here. So my output said for the first 0, 0, I got zeros for everything. Oops, why is this doing inserts? What if we did that? That was the problem, because that was returning as an int and doing integer division. Okay. Okay, so we got wrong answer with one of the outputs. Let me just see here. How many did we get? We got 11 out of 12, so it was on the last test case. And we didn't have any values, but it expects on October 4th that there was one. Ah, okay. So in this case, okay, I see what's happening. So in the case where there's a day where there's no completed drives and there's only one canceled drive, it's returning nothing because I'm filtering out the canceled ones. Okay. In here. So I think what we're going to do is, so I have to do another inner query here instead of just doing a count here. We're going to do another inner query, remove the status filter, remove these filters here. Let's try that. Okay, let me just see here. This is the third test case. My output had a record when they expected nothing. So they have a trip here that's canceled by the client. Users one, no client. Why would they expect no values for this one? Because there's one trip that was canceled by the client on that day. Neither of the users are banned, so the cancellation rate should be 100%. Let me look back to the description real quick. Oh, yeah, I missed that one last part. I just have to filter on the day. So where that's between that and that. Okay, we gotta divide by 0 on the fourth test here. So let's just kind of take a look at this. So there's a trip that is completed, and there's a banned user. Okay, so there we just have to say, well, in that case it's doing. Wait, let me in that case it's doing. It is doing divide by 0, but I just want to make sure. Yeah, because it's there's only one trip, so it's technically doing 0 divided by 0. Let's just do case when that equals 0, then 1 end. Is that okay? Then 1 else that end. Let's try that. It's expecting nothing. It's expecting to see nothing from that. Okay, I gotcha. It's expecting to see nothing from that day. So let me undo this. I'm going to undo that case. I'll go back to the description to add this back. So we are going to want to filter this, but it's a little bit different. Where that is greater than 0. Where that is greater than 0. Or that is greater than 0. All right. Finally got a success. So that hard one was actually a little bit more challenging. And in an actual SQL server, I'd probably end up making some views to make this less messy looking. Query looks too long, too many lines. It's like kind of confused. If I was to be walking into this a year from now, it'd be more confusing than it would have to be. You could abstract these inner queries out with either a function or a view. But all right, so let's go ahead and try to go through this real quick. So right here, obviously, we're just selecting the day, and the kind of whole point here is this is going to represent the amount of canceled orders for a given day. So we're getting that by, we're doing a count. I put 0 in here. You don't need to pull any particular columns. We just need to know the amount of rows. And we're casting that as a float because we need at least one of these values, either the top or the bottom, to be a float, because if you don't cast it, then it automatically takes count as an integer, because count always returns an integer. And so it'll do integer division and get the wrong answer. So cast at least one of them as a float so that you can do floating point division. And then we're going to select data from the trips table, inner joining on users with the driver ID equal to user's ID, and inner joining users again where the client ID is equal to user ID, where the status is in. So it's either going to be canceled by driver or canceled by client. And the trips table that in here, request at date, is going to be equal to the request at date from the outer query here, because we want to find the canceled orders for that day. And the driver and the client are both not banned. And this is just the total amount, not the ones that are canceled and are not canceled. It basically is the same query with that status filter removed. And that whole thing, we're doing a round on it to 2 decimal places, and then we're casting that to a numeric with 36 values and 2 precision after the decimal place, just to make sure all the numbers are going to fit. And then here in the outer query, we're selecting from trips inner joining with the user, the driver ID to the user table and the client ID to the user's table. We're making sure we filter to be in between the date range that they have listed, in between October 1st and October 3rd for 2013. And we need to make sure, because we have a case where the bottom, since we're doing division, of course, divide by 0. If this is 0, even if this is also 0, it's going to be a problem. So we need to make sure that we're only going to return records if either the top value or the bottom values are greater than 0. Now, of course, with the way these queries work, if the top value is greater than 0, the bottom query is going to be greater than 0, because the bottom query is always going to return additional results to the amount that the top result is going to return. So that's why this is safe to do. And this is basically the same. This is why I would abstract this out in a normal SQL server into either a function or a view, because this is the same query as this, and this is the same query as this. Just making sure that they're both greater, either one of them is at least greater than 0. And then we're grouping it by the date. So if there's multiple records on a date that it was returned, that it would group those together properly. All right, so that's going to be it for this one. Hope that helped you guys out. Thanks for watching. Catch you guys next time.